What up? Mr. Lee here. All right, this practice will be on reflecting functions. Okay, so you have all these transformations we've been talking about. We're only going to focus on reflecting. So if you look at what happens to the function, either we put a negative sign outside of the whole function, or we put a negative sign inside the function, right? So it depends what your parent function is. We'll see plenty of examples. Your negative on the outside reflects the function over the x-axis, and then the negative being added on the inside of the function reflects it over the y-axis. All right, so let's see what we have here. Functions f, solid, and g dashed are graphed. So they should be reflections of one another. They give us the equation of f of x. So it's this whole guy here. And they're asking what's the equation of g? And we have four options. Okay, so let's look at what we're given, these two graphs, and figure out how to describe the transformation first. It should be reflection. And then we'll see if it actually incorporates a negative on the outside or the inside of the function. Okay, so hopefully you guys can figure this out. This should be a reflection over the x-axis. Okay, so if I reflect either f or g across the x-axis, they should map on or land on top of each other. So we're looking at a reflection over the x-axis, which means, simply put, we have to incorporate the negative sign on the outside of the function. Okay, so watch what happens here. I'm going to put a negative sign in front of the whole thing. Let me actually open up a Desmo screen here so I can actually type in something. All I want to do is actually just type the equation in. So I'll just get a scientific calculator. Yeah, we'll do that. Okay, so f of x is equal to 1/4 of x plus 2 to the power of 3 and then minus 2. Okay, so this is what f of x is. And we said it's a reflection over the x-axis. So again, once more, we're going to put the negative sign in front of the whole thing. Okay, so watch what happens. The reason I'm showing you this is because we should have some distribution that happens. Okay, so I'm going to copy this whole thing again. But I'm going to put a parentheses around the whole f of x function, right? So I'm writing my new g of x function, but I first started by copying all of f of x. I'm going to put that in parentheses and then actually put a negative sign in front of that whole thing. That's what this means. Okay, I'm going to go back to the screen. If I have a negative f of x, you take the entirety of your f of x, which is here, in parentheses, and then take the negative of it. The reason that's important is because depending on how your function is simplified, we're going to have slightly different versions of it. Okay, so I can actually simplify this. Let me go one more step. If I distribute this negative, it's as if this negative gets applied to the 1/4 times all this x plus 2 cubed, and the negative also gets applied to this minus 2. Okay, so I'm going to erase this parentheses. It gets applied to this first term, but then you have to change this to a plus. Okay, so that's going to be a slight detail. Khan Academy is giving us multiple choice, so we don't see this version. If you wrote this version, let's say on our skills check, you'd still get the points. Okay, this is still correct. But to know which one is equivalent to it, we had to distribute, which means this minus actually turns into a plus. Okay, so we're actually looking at which one? We're looking at option B, right? Let's match that carefully. Yep, should be option B. Okay, there we go. Let's do a couple more here. All right, so we have the graph of f. This is our default. And then function g is defined as a negative f of a negative x. Okay, so let's see what happens here. We incorporated a negative in front of the whole function, and we incorporated a negative inside the function. Okay, so we actually have both reflections in this case. So we should take this function and reflect it twice. We're going to reflect it over the x-axis and then reflect it over the y-axis. It shouldn't matter what order, okay? And hopefully you guys can practice those reflecting skills. Okay, this one should just be mostly a visual because we also have multiple choice. If I reflect it over both axes, it should flip into this this quadrant here, right? So let's just do over the x first. It's going to pop up over here, And then if I flip it again, it'll pop up over here, right? Once x-axis and then another y-axis. So it should be option D. Option D is the only one that ends up in that top left quadrant, quadrant 2, if you guys know your numbers. Okay, so reflecting over both. Do one at a time, but it should be option D. Okay. Here we have a graph of f of x equals 2 to the power of x minus 1. So here's an exponential. Okay, so the exponential positions are a little more interesting, but it still follows this general format. Okay, if we are inside the function now, that means we're going to be in the exponent because it's an exponential function. Okay, so notice how your parentheses is up here. Let's see what this does. Okay, so this is the original f of x. We're going from f of x to g of x, right? So let's see that. Let's acknowledge what the differences are between f of x and g of x. Okay, so the first difference I see is we have a negative that goes out in front of the whole thing, and then we have a second one. We have a negative that goes in front of the x inside the exponent. Okay, so the minus 1 stays constant. You started with the minus 1, and then you end with the minus 1. So there should be no extra translation. We're only looking at the reflections. Okay, so this is another combo of negative on the outside, reflection over the x-axis, and then a negative on the inside gets incorporated, reflection over the y-axis. Okay, so let's see which one has both. If I flip it across both axes, you guys can practice your visual skills, right? This one will then, if I flip it over the y-axis first, it'll kind of look like this. And then I flip it again over the x-axis, it'll be over like this, okay? If you guys need to do some preliminary steps, I'm not going to show it on the video, but if you need to do some preliminary steps on like a Desmos calculator, you can do that. Just open up a graph. Okay, but we should get option B if we reflect it over both axes. Okay. Let's see. No. It should be option D, actually. See, I was doing that visually. Should be option D. So again, check with the calculator if you need to. But at least we were able to describe, hey, it was both the reflections. Okay. Okay, last one. Okay, so we have both functions graphed again. F solid, G dashed. So what's the equation of G in terms of F? So we don't have the exact equation. I like these examples because we don't have the exact equation, but we can figure out in general what's happening, and it's still going to follow all these rules. Okay, so if I start at F and want to end up at G, it looks like it's some kind of rotation, right? Or if you follow kind of the same format of what we did in the last two examples, we can have two reflections. Okay, so imagine you reflect F over the y-axis first, right? It'll then kind of pop up over here. And then if we flip it upside down across the x-axis, then it'll match with the dashed line here. Okay, another way to do it is just go point by point, right? If I take this kind of locator point, this is what, 1, -4. I can flip it over the y-axis. It'll then be -1, -4. And then I flip it over the x-axis, then it'll be -1, +4. So that proves that I did both reflections, okay? So if I did both reflections again, I have to incorporate the negative on the outside of the whole function and a negative on the inside. We're doing both, okay? So that means g of x should now be a negative f of a negative x, okay? So I think we had 3 examples where we flipped over both, but just know you can have, single ones where it's just one or the other. So keep using this chart. It'll be useful. Give it a try.